Hey guys, welcome to the go2hx May 2025 edition. This is coming out a little bit later because I was swept away with building the generics language feature into go2hx to be able to be supported in Haxe code, and I wanted it to be in a good place before I did any sort of monthly posting or uh, public discussion of the project because I wanted to make sure I would, what the actual position of the compiler was. So now that that's happened, I'm in a better position to be able to talk about it. So without further ado, let's get into it. First off, we have the multi-threading branch. So I made this branch in order to deal with one of the really sore points of the compiler, at least to me, and that was the compiler could handle small packages just fine, but it had a really, really hard time, if not impossible time, if you were on any type of consumer computer, to deal with large standard libraries or Go code, or more precisely Go code that had a lot of dependencies. And that was because all the code was being treated as a single instance. And that was a massive issue because if you wanted to send all the data over the network, or if you wanted to handle the packages, it would have to do it all in one go. And it just made it unattainable. I think that would be a good word to describe it for, consumer level grade computers to be able to handle it because they don't have enough memory. It would take, for instance, I remember I tried compiling that HTTP, I think 2 months ago, and I ended with the compiler was using 17 gigabytes of memory, and it was stuck for 4 minutes, and I had no idea what was happening, and I just gave up. And that's a huge issue. So I knew it had to be addressed. I knew there wasn't really any reason to beat around the bush now, especially given the huge momentum of the refactor that happened last month. And yeah, so I just went full in. I wanted to get this through. And at first it was small, it had a pretty small scope, but then it over time kind of grew because I realized, okay, because we were treating the system in a certain way, we assumed all these other criteria that no longer have to be the case. And these criteria, I think, overall were detrimental to the project. And so I'm happy that they're, in my view, fixed. So one of the things that we had to do because we couldn't handle large standard libraries, at least in the sense of, okay, I call go2hx and I want to compile NetHTTP. Yeah, that's not going to be possible unless we had this prior fix, this band-aid fix of, okay, we're going to compile all the standard libraries on the user's behalf and then put it into the repository. And so this was over 1 million lines of code. It was absolutely massive, and in my view, it didn't have any place to be in the compiler, but it was kind of just a way to keep moving. And so now having the per package compilation and being able to actually compile NetHTTP in any reasonable manner, which I think now it's very, very reasonable. Yeah, we no longer have to have this massive cache. We can simply allow anyone else that wants to use the compiler to compile all the standard libraries they want and nothing more. And then we ran into the issue of, okay, our cache doesn't, it's output based and it's not input based. So the issue I ran into a few times was, okay, I make some changes and I want to, I make some changes in NetHTTP or trying to get the compiler to work properly, and and then I have to compile all the standard libraries over again. And likewise for end user, it might be the case that, okay, I want to pull in X standard library with Y standard library, and then I want to pull in this third-party library that all uses it. And it kind of seems ridiculous to have to recompile, for instance, NetHTTP and all the dependencies 3 times again or 4 times again. And yeah, in order to address this, we wanted to switch to a different system, and that is an input-based system. So instead of before we had output where we would see the file contents that were going to be written to disk, but we'd have to do all the computation beforehand to actually, yeah, know what was going to be written to disk at the end. And that means that we didn't save any time in terms of computation really. But if we do input based, if we check instead what the Go files are in the beginning, and we see, okay, have we compiled any of these Go files before? And if we have, based on a cache checksum, then don't do any of the computation, just skip over it. And this makes it extremely nice to work with. Um, yeah, it's just really awesome. So that's the current system, and it's basically opened the door completely for NetHCP to be able to be compiled. And that leads into my other thing, and then the compiler now is also by default using HXCPP, and that's because in terms of it's a massive speed boost. It's it just it just fits the project quite well in terms of as a compiler target, as you need HXCPP in order to run the compiler. And yeah, so it's going to be the default. I highly recommend to use it that way, and that's all the instructions, the README are now going to be, it's going to include that HXCPP is a requirement. So there's that. Next up, we have the current state of the project. So right now we have, because NetHCP is able to be compiled, and that's the real current goal for the project, to be able to get NetHCP to be compiled and then to be able to be run and to build up a a web server using the Go standard library in Haxe. That is now all being tracked via issue 253. And so the issue is just a test case of showing, okay, this is a server and a client that are going to be set up, and I'm just running it over and over again and seeing if I can make progress with the changes that are being made. And all of the changes right now are all related to moving the needle along and making it so we can move up from, okay, it's the NetHCP compiles from go2hx, but now let's go to Haxe, and let's now have it so the output code can now be compiled using Haxe, and then afterwards is the runtime. So that's the state. It's pretty nice. I really can't complain. It's exactly where I want to be. And yeah, it's also, yeah, and we'll talk about the other thing that will come up, which is generics. So once that issue got created, I ran it, of course, and after a few fixes, I ran into the issue that generics are not implemented in the compiler. And this has been for a while that generics haven't been able to really be run in any manner in go2hx. There was a time beforehand, I think maybe half a year ago, where I had a partial implementation, but it was really not robust enough. It didn't have enough testing. It didn't meet most of the criteria. But for the longest time I had an idea of kind of, if I were to do it again, here's how I do it. And so running NetHCP and running into a compilation issue with generics, I decided, okay, I'm on a roll here. I gotta do another. I gotta take on even more ambitious things in order to get this project finished and in a good state. So let's do generics. Let's do the last language feature. So sure enough, I got into it. I had the extremely ambitious goal that I could finish it by the end of May. That did not happen, of course, because I live in reality, unfortunately. But I am very happy to say that it is now actually merged into the compiler, and it is in an extremely good state. It's not perfect by any means. It has some edge cases, but overall it's extremely robust. It and it can pretty much cover everything that we want to do with getting, yeah, NetHCP compiled and pretty much all the other standard libraries for the most part. So there's that. And I should probably also cover Well, why can't you just use Haxe generics? How is it actually this complicated? Why does it take you 2.5 weeks after you've been thinking about it for 6 months? Well, these are all good questions, and I can answer them. The generic system in Go is a lot more TypeScript-esque. It has, for instance, a union type, so you can have multiple types, and the compiler will be able to figure out between these types what are shared in common, and then it can. So, for instance, you can have an int and you can have a string, and then it will know that because these two have a operator of plus, they can both be done on that generic type. And so you have cases like that. You have cases where you can have a type that, for instance, constrains all comparable types, all ordered types, and you also even have any, which can constrain anything. And so it's not trivial to try and represent it in Haxe generics. I don't think it's possible. So instead, what we had to do is we had to use a mixture between overloads and Haxe generics to be able to support Go's generics. And overall, it's actually in quite a good spot. It's now relieved the NetHTTP compilation issue, and it's now moving along quite swimmingly. So yeah, there's that. It's also it should be noteworthy as well that it's the last go2hx language feature that needs to be supported, at least that I want to support as the sub-specification of go2hx. So for instance, of course, we can mention cgo and unsafe and other things, but in terms of core language, in terms of getting the most amount of standard libraries and having this be an actual compiler, generics has to be included because it's such a core part of Go now as a language. Unfortunately, I mean, fortunately, it's nice, it's really nice, but yeah, it was extremely not trivial to support it. And, but yeah, I think it's overall a good feature. And now that it's in, also another thing to note, which is also cool, is that the compi go2hx is the first compiler outside of the Go compiler to actually support generics. So you have, for instance, TinyGo that supports generics, but it uses the SSA form. And that means that it basically transforms it all of the AST information, it transforms it into a lower level version, and then that will actually have generics in it. So go2hx is the first AST compiler to support Go's generics. So I think that's pretty cool. That's definitely a headline to run with. And yeah, overall, it opens the door to pretty much the rest of the language in the ecosystem. So yeah, okay, now on to pull requests by other people. This looks a little bit deceiving because it shows me commented last month, and but Elliot made all the changes. He is the core architect to this, and he improved the go-to system for go2hx. So before there was some edge cases that were really not easy to fix and were causing headaches. And Elliot really kindly went ahead and fixed those issues. So thank you, Elliot. And now go2 is a better spot, and it's used in a lot of standard libraries and other things. I wouldn't recommend you use go2s, especially because you can in Haxe, but yeah, it's there. It needs to be supported, and it's in a better spot because of Elliot. So next up, Makai. He documented a Windows setup issue. So for instance, we have the go2hx compiler, which no longer requires Go to be installed initially. It can actually install it for you on your behalf, and it picks the correct version that go2hx requires. And it was having issues in Windows, so he pointed it out, which is really nice of him, and now it's fixed. So props to Makai for pointing that out. Then we have Yassine. He found a bug with using the empty, I think it's like a variable or something. I forgot exactly the name of it, but it's the underline variables, and in this case you can have it if you have in this certain given configuration, it breaks the assignment to the second value. And so really nice fix and, or not fix, sorry, a really nice identification of the issue. And it's still not fixed yet, but it will get fixed eventually. And yeah, so appreciate Yasin for pointing it out. And finally, we have Euro Ali, who saved me on a very rare occasion, of course, of me going crazy, which was I was trying to implement the threaded branch on my Mac computer, and I was just totally stuck in terms of what the issue was. I was getting not even a seg fault. I was getting no no real identification of what the issue was, and I could not figure it out for the life of me. And it also depended in terms of if I added variables in or if I changed cases that would never be touched for some reason that would cause it to crash versus not. And so the origin of all my suffering in that regard was Mac has a default stack size for threads at 512 kilobytes, whereas I think all other ones have a much bigger size. Yeah, for sure. Windows and Linux. And yeah, so this is him. He went ahead and took some of his gracious time and fixed it, or not fixed it, but pointed it out and let me use one of his forks of HXCPP and showed how he changes the stack size. So extremely helpful. So thanks to EuroAlley for pointing that out and saving me a massive headache. So that wraps up the contributors for May. So we have Elliot, Stoneham, Mackay, EuroAlley, Yasin, and myself. Good month. Quite happy with it. Yeah. And finally, I'd like to thank you guys for watching. I hope the format was good, by the way. I don't know. I wanted to kind of have it be a little bit more informal. I like the formality in terms of nice editing and whatnot, but I needed to get a video out, and yeah, I don't know. It takes a lot of time doing the editing and other things, and so I'd be curious to hear what your thoughts on in terms of the format. If you if you like last month's more than this month's, or if you like this month's more. I'm happy to go off the cuff a little bit more. I know it's might not be as nice in terms of the viewing experience or the hearing experience if I might have a little bit longer pauses or if I'm not as sharp to be able to say everything, but yeah, we'll see. I don't know. But yeah, thanks for watching. On to next month. Cheers.